So now we are studying about conventional abrasive processes wherein we have completed like grinding, honing and lapping. Now we are proceeding towards the super finishing process. The overview of the lecture, normally we start with the introduction to super finishing, then the types of super finishing processes, advantages and applications of super finishing. Then we move to sandblasting and microblasting and vibratory bowl finishing, tumbling and the summary, and other processes also we will see if there are like pitch polishing and other things. So, as we have seen this particular graph, if you see the roughness versus the manufacturing cost, as you see the three processes like lapping, honing we have completed. Now we proceeded towards the super finishing process. So, these are the final processes that you do in a manufacturing of certain component. Okay. So, the cost of this particular process will goes up if the requirements of your surface roughness is very low. The surface roughness requirements versus the cost of the process is inversely proportional. If the surface roughness requirement is low, that means that super finishing is required, then the cost of the product will goes up. So, one of the processes where you complete the manufacturing of component is like super finishing process. The super finishing process, if you see, it goes like you have a workpiece, the cylindrical workpiece is given here, and you have a abrasive stone. Basically you have abrasive super finishing stone, or abrasive stone is this one, or bonded abrasive stone you can say here. Okay. So, you will put some coolant or the lubricant, so that if there is any temperature generation and other flushing of the chips and all those things, for that purpose you always put the cutting fluid or the coolant here. Okay. So, similar to the honing process, this is super finishing is similar to the honing process, but uses bonded abrasive stick basically, and that press against the surface and reciprocation motion is provided to it. Okay. If you see here, as you saw in the previous slide, the rotational motion is provided to the workpiece and bonded abrasive stick is there here, and this is reciprocated. Okay. So, this will be provided the reciprocation motion, so that you will get the finishing operation. Okay. Normally this reciprocation will be done at low amplitude and high frequency. That means that it will be done at very fast with a low amplitude. That means that the reciprocating distance will be very less, but the reciprocating frequency is very high. Okay. Difference between honing and super finishing process, if you see shorter strokes, whereas in honing process you will have seen that it is reciprocates and rotates. So, it will have a throughout the engine block or something. So, the strokes are very high, stroke amplitudes are very high in terms of honing process, but strokes are very less, but the frequency is very high. Frequencies are very high in this particular process, but in the frequency in honing is very less. Lower pressures between tool and surface, normally this is a stone, flexible stone. So, the pressures are obviously very low, and the similar to abrasive particle size, smaller abrasive particle sizes will be used. Normally super finishing will use smaller abrasive particles compared to the honing process, because of which you will get better surface finish compared to your honing process. In the introduction to super finishing process is a micro finishing process that produces controlled surface condition on the workpiece. That means that you can get the controlled surface roughness as per your requirement. If at all I want certain surface roughness, then you have to play with your reciprocating frequency, amplitude, as well as how much pressure you are going to put. If you can control those things, you can get the controlled surface roughness. This process is also called as micro stoning process, because you are using a stone wherein the abrasives are there and which you are pressing against the workpiece. It consists of scrubbing of a stone against a surface that produces the fine surface quality or surface finish. That's why this process is called as a micro stoning. As this particular sentence says that you have a stone like structure which is reciprocating with a lower amplitude with high frequency. That is what the sentence says. The process consists of removing of charter marks, normally chartering marks in terms of milling, in terms of turning process in lathe, and fragmented or smeared material from the surface of dimensionally finished product. So, if at all I want to finish or deburring operation or the removing of the chartering marks, you can use this particular process. So, as much as 0.03 to 0.05 mm stock can be efficiently removed. That means that this is the amount of material that it can remove in some of the production applications. The process becomes most economical if the material removal is less than or limited to 0.005 mm. If the material removal is very less, that means that if it is considered to be a finishing process, then its efficiency is better. That means that it can give you good surface finish rather than good material removal. That means that we have seen the machining process as well as finishing process. A machining process is the process where your material removal is the criteria. In a finishing process, your surface roughness or the final surface finish that you are going to get is the criteria. If at all your criteria is the surface roughness or the final surface finish that you want to get, then this particular process, that is super finishing, works very well. Okay. The super finishing commonly comes under the micro nano finishing. This is achieved by removing a just thin amorphous surface layers that like 1 micron in magnitude left by the previous processes like turning process or milling process or any other pre-processes which are removed, the feed marks or charter marks, those are removed. That is why this particular process comes under micro to nano surface. Even you people can get nano surface finish if you can control properly. The super finishing, unlike polishing which produces the mirror finishes, okay. So, this can give the mirror surface finish, that is what I was telling. So, it can give you a nano surface roughnesses and creates a pattern on the workpiece. So, it also creates some texture on the workpiece. That means that it not only gives the mirror surface finish or the nano surface finish, but also it can generate its own lay, that is predominant direction of surface roughness on, and this application or this texture application may be used in many products. So, types of super finishing processes, there are two types, one is plunge type of super finishing, another one is wheel type of super finishing. So, in the plunge type of super finishing, this type is normally used to finish irregular shaped surfaces. The workpiece is rotated while the abrasive stone plunges into the desired surface. That means that the workpiece surface. If you see here in the picture, this is a workpiece where which is rotated, and this is the abrasive stone which is plunging on the surface. Okay. So, at the same time oscillatory motion or the reciprocation with slight amplitude with high frequency will be given, and this is the pressure that is giving on that one. Okay. So, that like this the pressure will be given. Okay. This is a stone, and whenever the pressure is kept on the stone puts some normal pressure on that one, and this not only the normal pressure, it also reciprocates very small distances, but with very high frequency. That is what we have seen in the previous slides. It is used for finishing of piston pins. Normally, some of the examples where you will use is the piston pins, cam followers and rollers and piston rods. These are the common applications where you will use the plunge type of super finishing, and normally the surface finish can be obtained up to 0.2 microns of average surface roughness. Okay. RA stands for CLA, that is nothing but central line average value. The second type is wheel type of super finishing process. These abrasive cups or wheels are used to super finish the flat and spherical surfaces. Normally, cups and wheels are used here to super finish flat as well as spherical surfaces. Okay. So, wheel and the workpieces are rotated opposite direction, which creates a crosshatch pattern. Normally, you have seen the crosshatch pattern will be provided are generated in the honing process, because it is goes like this and comes in the opposite direction. So, along with the reciprocation, rotary motion is there, but the direction of rotary motion will be opposite when it is coming out. That is why you will get a cross hatch pattern. Rather than that, in this particular super finishing, where the second type of super finishing process, which is wheel type of super finishing process, you will have two rollers. These two rolls rotate in opposite direction, so that the finishing will be obviously taking place. At the same time, the surface texture that you have to generate will be the cross hatch pattern type. If the two rollers are parallel, then the result is in the flat finish, but if the wheels are tilted slightly, then the convex and concave surfaces will form. Normally, if you both are rotating in the parallel direction, that means the same direction, then you will get the flat finishing surface. And if you are going to tilt these rollers, like tilting like this or tilting like this, what will happen is that you will get according to concave shape or convex shape. On this concave shape and convex shape, you will get finishing, and the rotation of this one will decide on that particular concave or convex whether you want to go for a cross hatch pattern or parallel lines or something. Okay. So, dimensions of the job can be varied from diameter of 25 to 150 mm and the length is 2000 mm. That means you can do the super finishing operation using this particular method of diameter ranging from 25 to 150, and the length will be approximately like 2 meters. Okay, that is 2000 mm you can do. It is capable to finish the surface roughness of approximately 0.3 micrometers to 0.025 micrometers of centerline average value. This particular process will be normally used for super finishing of hydraulic cylinders, piston rods, shock absorbers, as well as IC engine parts. These are some of the components that can be finished using wheel type of super finishing process. If you see that super finishing, normally this is the initial surface. Initial surface roughness, and this is the final surface roughness. Okay, what is it is going to take place here? So, whenever the plunge type of thing, if you assume a plunge type of load is applied on this, what will happen? It will put a normal pressure, and a height wise it will goes off in each rotation, and whenever the load is applied, normally gradually it goes off. So, whenever it goes off, what will happen? It will changes from this to second one, 1, 2, 2, it will move. Then if you remove still more, what will happen? So, you will get the 3, and coming from 1 to 2, it will take some time. The finishing time will be like half an hour or 10 minutes or something, depend on what is the plunge load that you are using, what is the frequency that you are using, what is the reciprocating amplitude that you are using. Reciprocating amplitude normally will be used for very lengthy workpieces are there, then only you will go for multiple passes. Otherwise, you can go for a single pass or something. So, 2 to 3 it will take some time. So, it is not a one time finishing process, or one stroke you do not get this particular. So, you need to go for 100 or 200 strokes, so that you will get 1 to 2, 2 to 3, then followed by the 4, and finally you will get 5, so that you can get a super finished surface. That means that initial surface peaks are sheared gradually. Okay, so that these peaks goes away, or the sheared away by the stone in terms of, and this will exit from the particular surface as microchips. So, advantages of super finishing processes, it increases the parts life. That means that whenever the super finishing is there on the surface, so wear and tear will be very less. As you have seen in the previous slide, the surface is very rough like this. In that circumstances, whenever some load is applied, for a practical applications, what will happen? The load will be bared by only peaks. So, the life, this will deform and the eccentricity problems will come if you assume like a shaft as well as bush and shaft conditions. Okay, eccentricity will come, so the life will fail. So, decreasing the wear, normally if the surface roughness is very low, that means that finish is very high, so the wear will be very low. Here in this condition, if the roughness is very high, the wear will be very high. If the surface roughness is low, the wear will be very low. And close tolerances, you will always achieve the close tolerances because the surface finish is very low, that means that it is fine finish. So, obviously your surface is smooth and your perfectness will be very high. That is why your tolerances will be closer as per the requirement of the customer. Higher load bearing surfaces. So, if you see in this particular picture, so the bearing surface is very less. If you see the surface is like this, on top of it if you put the same load, what will happen? The bearing surface is very high. Here the bearing surface is, in figure 1 the bearing surface is only the peaks. Here in figure 2 the bearing surface is very high for the same load. Okay. So, the surface roughness decreases, the bearing area, more and more bearing area come into existence to oppose the load. So, the better sealing capabilities, in the first case the better sealing capabilities will not be there, in the second case it will be there, because if this type of, in figure 1 you will have lot of space. So, the sealing will be, the gas or the air can be entrapped or it can pass through these peaks and valleys, but which is not in case of figure 2. So, elimination of break-in period, normally you can eliminate the break-in period, that means that you can improve the life. Disadvantages, the super finishing requires grinding or hard upturning operation prior operation. So, it will require a pre-operation like grinding or hard turning, which is a costly process. And super finishing has a lower cutting efficiency because the chips that you are generating is very small. So, if the chips are very small, what will happen? The specific energy requirement will be more. See, super finishing stones are softer and wears quickly, however they do not need any dressing or something, because the advantage is that they do not require any dressing, but these are all soft stones. So, this will wear very fastly. So, that these are the 3 disadvantages. Applications of super finishing, if you see the applications of super finishing, so you can see the cylinders are super finished here, multiple go, they are doing the finishing operation, and you can see the brush, here the brush is or the stone, you can clearly see the stone which is applying the slurry, on top of it, it is finishing. At the same time you can see the zoomed version of this particular portion. So, okay. So, you can see these are the cams, followers, irregular shapes can be polished or super finished using the super finishing operation. At the same time, normally this is a abrasive process where you can have the more amount of abrasion. That is why always people used to go for the lubricating type of cutting fluids or pure lubrications the people uses here for the polishing of any irregular surfaces or irregular surfaces in both type of super finishing operations like plunge or cylindrical, wherever you require. Okay. Now, we have completed the super finishing operation. Now, we are moving to sandblasting and microblasting. First, we will see the sandblasting. So, sandblasting normally uses the sand, commonly available sand, SiO2 sand, or varieties of sands are available commercially. At the same time, you can also use by sieving the existing some of the garnet sand and other things which are available at economical price. The sandblasting uses compressed air to blast the fine sand or other abrasives through the nozzle. Actually, there will be a nozzle through which you will send the compressed air along with the sand particles or the abrasive particles, so that you can impinge on the surface to be blasted. The sandblasting is one of the most effective ways to shape or strip and smooth the surface. Okay, that means that if at all I want to remove a certain layer, assume that I have a oxide film formation on a particular object, so I can do the sandblasting and I can remove that surface, which I will show in the next slides. Okay, that is called stripping. You can strip some of the layers. Assume that some coating is done on a certain surface and I don't want that, then you can do the stripping of that layer by using the sandblasting, and you can do the smoothing, assuming that I want to finish up to certain level. You cannot get a nano finish or a atomic level super finish, you may not get in the sandblasting, but you can cover a wide area of finishing in the sandblasting operation. So you can shape it also. Some of the casting products whenever come out, so you can do the sandblasting and you can remove the surface layers. Easy to finish of the nooks and corners. Normally complicated shapes are there. The people normally they will be using this nozzle jets. So they will go and put to the nook and corner, like assume that this is the jet. So you can put as per your requirement. If it is nook is there, like that you can put, or like this, like that you can put. As per the requirement of the component, people can orient their hand so that it can reach to the nook and corner of the complex components. So create virgin like surfaces. That means that if the surface is became bad or something, so you can generate like a virginal surface. Materials other than sand which are used is steel grits and steel shots, glass beads, black beauty, and groundnut shells and corn cobs you can use, and mostly people also can use aluminum oxide as the abrasive particles for sandblasting applications. So aluminum oxide, as I was telling you, cold slag also can be used, and brown aluminum oxide and black aluminum oxide. There are varieties of aluminum oxide that are used, and this can be pumped along with the highly compressed air, so that you can blast on a object or a workpiece that you want to shape, or you want to strip certain layers, or you want to create a virgin surface or something, you can do it. Okay, these are the some of the glass beads, or these are the steel balls. Now you can see here the ball sizes and other things. If you see particularly this one zoomed version, you can see here. So S780 to S170, you can see these very fine particles. Of 780 you have big size particles, or big size rollers, or it is called big size of spheres are there, which are made up of metals. As you decrease the number of particles per unit area is increasing. So it means that number of spheres are increasing. At the same time, you can use the other abrasive particles also for sandblasting applications. The sandblasting main purpose, it is used to clean the workpiece surface and remove the impurities as well as suspended particles. If you see this particular figure, what will happen? This is the initial surface which is transformed into final good surface. Okay, so assume that I have a oxide film or a rusted film is there, on that is removed. At the same time, the surface is contoured. That means the surface pattern is different. You have a different contours, nooks and corner your sand has to reach. For that purpose, you can use the sandblasting. So sandblasting can reach to nook and corner of this rim, and it will remove or strip off the rusted portion, and you transformed from rusted state to very good state, or you can generate a virgin type of look on the rim that is rusted. You can also see this is initial and this is final. So now if you want to generate certain small jobs, so this is sandblasting is one of the opportunity for low amount businesses. If you want to open a small scale businesses and all those things, you can get these type of rims. If you think that mechanically these are worth or mechanical strength is same as the virgin one, so you can use the sandblasting and you can create the new one and you can sell to the secondary people, so that you can achieve you can move in a profitable way. So the sandblasting can be one of the opportunity for a small scale industry. I cannot say small scale industry, for a small people who want to open, and you can earn your daily money. At the same time, you can generate these things for the people who like small applications like tractors or small automobiles. You may not require very high strengths. If you have rusted things, then you can repair it and you can resell it for the economic price. You may not sell at the original price, you can sell at the economic price by telling the people genuinely that these are all done by sandblasting and we are reselling it. It is the old one, but we are giving you by reselling it, so that you can earn your livelihood also. Some people, this can be a good opportunity. At this particular business, you can expand from small to medium to big also in later case, if you think that it is a profitable job. That is one type of manufacturing process that you can make for livelihood. So types of sandblaster machines, normally automatic sandblaster will be there. So this is the one type where you can eliminate the use of manual movement of either short stream. Just you can put inside this one and you can blast. Okay, there is no emissions. We will see the emissions and other things in the upcoming slides. The basic problem here is the emissions. Whenever you blast on a surface, lot of dust will be generated. This dust and other things will cause the operator as well as surroundings very polluted atmosphere, and this particulate matter can enter into the nose, enter into the mouth, and it will create a lungs scratches on that and silicosis problem and other problems it will create. For that purpose, this automatic machine is there. Just you feed your workpiece, you can feed your sand particles and you can set your all the input parameters like what is the pressure at which it has to impinge on the workpiece and other things. So it will do the process, but the constraint is that you can do only for a limited size of the samples. If you have a very big samples, you may not able to do. Other one is blast cabinets. You might have seen the cabinets for bio applications, fume applications, other thing, fume hoods and other thing. These are the cabinets which is a enclosure in which items are placed and abraded. Normally these items are placed and inside this one you can blast the components. Assume that the previous rim is there, just you put inside the cabinet and you just direct this one, so that in the some of the cabinets you can put your hand, like a gloves will be there, rubber type of gloves will be there, just you put it and hold the nozzle and you can do that like operation. Assume that this is my nozzle, so which is there inside the cabinet, so there will be a rubber type of gloves will be there, so which is inbuilt of a cabinet. Just you put it and you hold it and you don't have a physical appearance of your hand inside, but you have a rubber thing which is protected your hand. Just you do as per the requirement of that one, so that you can do within the cabinet, so there won't be any problem of pollution. So there are modes of applications or the methods. One is the dry sand blasting, another one is a wet sand blasting. If you see in a dry sand blasting, you have a mechanical blasting and air pressure blasting. In the wet, you have hydro blast process as well as vapor blast process, wherein in the wet, what is, you will replace your air with respect to by using a liquid jets. Okay, so if you see the mechanical blasting, so you have a feed out, like you are flowing the abrasive particles and impellers and case for there, and just you blast on the surface and this surface will be cleaned. Okay, so you have compressed air as well as abrasive particles which you are blasting on the surface. Okay. The other one is induction gravity method, wherein you have the abrasive hopper where you place the abrasive particles and it will come through this one. At the same time you have a compressed air jet which is coming from here. So both will mix and comes out and your object will be here. So it will be blasted on this one, so that you can get the good surface finish, or if at all I want to remove certain layers, unwanted layers like rusting layers or something, you can remove it. But in case of rusting layers removal and other things, you have to use the nozzle angle at certain angle. Those also we will see in the upcoming slides. In the wet sand blasting, which is a hydro blast process, sand is mixed with water and propelled by the water pressure. Instead of compressed air, we are going to use the compressed water, highly pressurized water jet will be used. In this case, what will happen? The divergence will be very less. If the divergence is very less, what will happen? The dust creation, other things will be very less, and the precise shapes you will get. In the vapor blast process, abrasives are suspended in a liquid projected with a high velocity by a jet of compressed vapor, steam or other streams. Normally you will have vapor along with the water as well as the abrasive. Some people they may use with the vapor only, or some people they will also mix with this one, so that what will happen, it will become more and more effective. Your divergence will reduces and dust and other things will be reduced. In sand blasting input parameters, if you see, the air pressure is the first and primary thing, that air pressure at high air pressure. So you will make the blasting faster. If the pressure is very high, the velocity at which the abrasive particles will move will be very fast. Okay. Thus, the lower pressures allow the slower blasting for more control. If at all I want to remove more material from the surface, or if I want to delaminate a particular layer, so you have to go for higher air pressures. If at all you want to have a controlled surface, then you have to go for medium or low level of air pressures. So the nozzle size, the larger nozzle sprays a wide pattern, making it easier for uniform texture. So for the larger surface area and other things, if at all I want to make some texture, so I mean to say some engineered surface, so you have to go for larger, and the smaller nozzles better for the fine pattern, better for the fine details control. If at all I want to control in a particular space or in a small area, controlled texturing, then you can go for a small one. If at all I want to do very controlled texturing in a large space or a large area, then you have to go for a big nozzle. But in a big nozzle, you may not have that much control over the surface that you are going to get in a small nozzle. So the blast distance is the distance between the workpiece to the nozzle exit. So the blasting from farther away spreads over the wide and area and more likely to produce more uniform pattern. Blasting in closer area will have the finer controls. That means that if I am blasting from far away, assume that my workpiece is here, if my blasting distance is very small, if my nozzle is here, in that circumstances what will happen? You will get a finer surface texturing. If I am going broader, in that circumstances what will happen? The divergence will be very high. If the divergence is very high, so you will get a large area, but the impact pressure or impact force on particular surface, if the distance is increasing, will be very low. So as the distance is increasing, the blasting distance is increasing, so the impact force that is exerting on the workpiece surface will be less. That means that the depth of indentation by the abrasive particle will be gradually reduces if the distance increases. Okay, the blasting parameters, if you see angle of blasting, normally varying angle of blasting, so will allow you to create variable contour shapes. Now that means that if at all I want to go for various angles, so what will happen? You can generate different contours. As you see in this particular picture or the figure, if I am going for straight one, so what I am going to get is, you will get a feature like this, because so you are going to get a divergence here. So if your nozzle is like this, what will happen? Your divergence will get, your blasting will takes place in this direction. So you are going to get the feature like this. If at all I am going for certain inclination like approximately 45 degrees or something, so you will get a feature like this. On this the contour will be different and another the contour will be different. So there will be a change in the contour. If you are going for the medium angle like this one, what you will get is this type of contour. So if at all I want to change, or if my requirement of the contour on particular surface is different, then you can go for the slight angle to the medium angle to the hard angle. Okay, hard angle, that means that you, in this case you may be like 30 degrees. This degrees whatever I am writing here is approximately, okay, may not be exactly, okay. So you will get the contours. At the same time, your inclination also helps in delaminating. Assume that I have particular surface wherein I have a coating. Assume that I have a coating which I don't want this coating for certain applications. This is my workpiece and this is my coating. Okay. So in that circumstances, if I want to delaminate, just I will go for hard angle implement. It will delaminate the surface, or it will delaminate the coating which is coated on this one. This is nothing but the coating, and this is workpiece surface. Okay. So this is my angle of impingement of my abrasives. In that circumstances, I can delaminate this particular layer here. Okay. So what I mean to say is that this angle of declination or changing from slight angle to the hard angle will also help you to remove the unwanted layer. As you have seen in the previous slide, there is a rusting layer, oxide film is formed on the rim. So if I want to remove, then better to give certain inclination to the blasting jet. If you give inclination, then it won't create the craters on the surface. If you put like this, what will happen? It will generate the craters. If you put like this, what will happen? It can delaminate the oxide film, and you can get a beautiful virgin like structure or virgin like surface. Then you can paint it and you can resell it. So abrasive ratio, the abrasive ratio can be controlled and varied with the pressure blaster. That means that if you, whatever the pressure is there, depend on that your abrasive ratio will go. Abrasive ratio, normally the abrasive particles to the normally the air that is flowing. Okay. So if your air pressure is very high and abrasive particles are very less, the abrasive ratio is very less. So if at all you want to go for higher ratio of the blast, faster, and lower ratio for the slower. Normally ratio, if it is very low, what will happen? If I want to blast very fast, that means that material removal I want very high, then you can go for faster one. If at all I want to go for less material removal or uniform surface, for that you can go for lower ratio for the slower. It may be desirable for fine control. Normally that means if at all you are going for lower ratios, then you can go for finer control of the surface. That means that you will get a uniform surface. If you are going for very high ratios, then the impingement of abrasive particles will be very high and the material removal will be very fast. So the uniform surface you may not get. Okay. If at all your requirement is to finish uniformly the surface, then you have to go for the lower abrasive ratios. Micro abrasive blasting, if you see the micro abrasive blasting, normally it is the same thing such as sandblasting, but here you will, particle sizes are very fine. I mean to say ultra fine, like mesh sizes crosses like 1000. So that means that your particle size will be 10 microns, 15 microns or below, and it will pass through a very fine nozzles. Okay. So these are the fine nozzles which are impinging on the workpiece. Okay. These are the burrs, some of the burrs are remaining. So deburring action is taking place in this particular thing by the microblasting. So the powder comprised of spherical micro-sized glass beads or silicon carbide or alumina or sodium bicarbonate for polymer implants. Normally sodium bicarbonate can be used for polymer. Otherwise, if it is a metal, then you can go for silicon carbide or alumina. So mostly used for stents. Normally stents, metallic stents are fabricated by micro mechanical machining or micro laser machining, EDM and other things they will use. So there may be some layers they want to remove, or some deburring has to be done on that surface. For that purpose, this micro blasting will be used. So the deburring of these stents and cages will be done. Other thing is that to remove oxide layers from the surfaces and striations left by the laser machining. That means that if there is any striations, normally laser beam passes one pass, it is a pulse by pulse by pulse. So there will be some milling type of feed marks will be there, like remelting zones will be there, like a milling marks. So these are oxide layers, or sometimes some people they will use for under liquid laser beam machining. In that circumstances, if your liquid is a carbon based liquid, then you have carbides. So in order to remove all these things and at the same time to make textures also on the surface, so you will have to do the microblasting operation. So this abrasives creates micro nano dimples or dents on the surface. So normally for the bio applications like stents and other things, you require super hydrophilic surface, because you have to have cells attachment, or artery has to attach properly on the top surface of this coronary stents. For that purpose, you may need to do some texturing. That texturing some of the people will do by this microblasting. That the nano finishing is not achieved due to size limitation of abrasive particles. That means that if the abrasive particles are very big, like 15 microns or 20 microns, then its sharp edges are approximately 1 micron or slightly higher side. In that circumstances, you may not achieve the surface finish in a nanoscale. The abrasive embedded on the ductile surface. Normally, if at all I want to do this particular blasting for aluminum, this type of ductile materials, what will happen? Whenever you impinge, these particular particles will go and embed inside. So that is the biggest problem. Then machining also will become more problematic. So if this is aluminum and abrasive particle went and sits here or embed here, the next abrasive particles will come and hit. So rather than creating some pattern on the surface, it will have deteriorated surface by embedding of a series of abrasive particles. So this is one of the drawbacks of this particular process. The sandblasting normally uses the compressed air. At the same time, sand was sieved to get the uniform size. Assume that you have to sieve it. If you can sieve it, what will happen? You will get a uniform size of particles. Otherwise, if big particle is there, it will go and create a big crater. If small particles are there, it won't create. Then you will get a non-uniform surface. For this is not required, or this is not desired by a manufacturing engineer. To get a super uniform surface, you always should go for a uniform abrasive sizes. For that one, you have to use the sieves. There are standard sieves, so you can use these sieves and get the uniform abrasive particle sizes, so that you can get a uniform surface on the workpiece. The silica dust is produced for sandblasting can be yield silicosis. This one we will see in the next upcoming slides. Many of the industries, they will use the silica dust, which is economically available in the market or on the other areas. So they will use this particular thing, and which may causes the silicosis, and you will see one of the example how the silicosis will be caused, and other things will be seen in the upcoming slides. This silicosis is a chronic lungs disease due to continuous inhalation of silica dust particles by the operator. However, this may be prevented by using a protective clothing or breathing air supply. That means that if can prevent this silicosis by having a mask, apron and other things, protective things can be provided by the company to the operator. Alternative to sand, glasses, glass beads, metal pellets and dry ice powdered abrasives of various fine sizes ground coconut oil shells can be used. Instead of silica, if people can provide or the company can provide the metal pellets or dry ice or powdered abrasive particles, other particles, then the silicosis level may be reduced. Okay. So, that means that it is says that metal pellets or dry ice powder particles can be provided instead of silica particles. So, as we have seen in the previous slide, silicosis is one of the problems and we will see as how this will affect or how it will be acquired by the operator. Hazardous air pollutants, typically particulate metals, are emitted from the abrasive blasting operations, and these emissions depend on both size of the abrasive material and the target surface. Your abrasive particles are ceramic particles, it will go and indent on the surface. Whenever it will indent, depend on the hardness ratio, that means that particle hardness to the workpiece hardness, there will be a lot of mechanical changes will takes place in the particles. At the same time, if it is workpiece also a brittle material, this will also emit some of the particulate matter. At the same time, if it is going to hit, these are ceramic particles, this abrasive particles are ceramic particles, this also will have the brittle fracture. If the brittle fracture and here also brittle fracture, then the dust will come. This dust can go into the operator if he is not wearing the mask, apron and other things. Particulate matter is a major concern relative to the abrasive blasting. The particulate matter emission is a function of wind speed. That means that the how much air pressure you are. If your air pressure is very high, what will happen? The pressure as the impinging force will be very high. If the impinging force will be very high, if the hardness ratio is very less, that means that the abrasive particles will become pieces and it will emit a lot of particulate matter which can enter into the alveolar region or lungs region of the operator. Higher wind speed, that means air pressures, increases emissions and enhanced ventilation of this process by the retardation of the coarse particle size. Not only this one, the wind which is there, if the wind is there, ventilation and wind is there, then what will happen? It may also, the wind try to go up because the density is very less. In that circumstances, the operator may be inhaled this particular particulate matter. Emission particulates equal or size less than 10 to 2.5 microns in the aerodynamic diameter, that is approximately 13 to 1.3 kg per megagram respectively. Emissions of particulate matter size are affected not significantly wind speed dependent. There are two types of particles. Assume that if the particulate size is less than 10 microns, it can enter into the nose, no problem, but it cannot enter into the alveolar region of the operator. Alveolar region is nothing but the intricate zones of the lungs of the operator. In that circumstances, not very big problem, but still it is a problem. If the particle size is 2.5 microns or less than that one, in that circumstances what will happen? It will enter into the alveolar region and it will block the alveolar pores, then it will be a very big problem. Okay. But what this particular statement says is, if the particulate size is less than 10 microns or normally 2.5 microns, wind speed may not affect, okay, because the surface area is very high. If you see the silicosis, normally the X-ray of a patient, so whose lung silicosis as a result of sandblasting, normally silica particles, if sandblasting is done with the silica particles are coming from one side, compressed air is coming from the mixing and going onto the surface. In that circumstances, what will happen is the silica dust will come out. The silica dust will be inhaled by the operator and this will cause lot of problems like silicosis. You can see here, this is the silicosis that is occurred in the lungs of a particular patient. This lungs is good and this is silicosis. Affected lungs. Okay. So, if you are an engineer and your companies does the sandblasting and other things, as a humanitarian grounds, as a manufacturing engineer, it is your primary responsibility to provide the apron, mask and all the protective things to the operator, so that you can save a operator. If he is healthy, he will do more and more work for your company. Okay, keeping in mind, as a manufacturing engineer, it is our primary responsibility to take care about the shop floor people also. So, emission control, how do you control? The number of methods have been used to control the emissions in the abrasive blasting. The methods include blast enclosures, which we will see. We have seen already these enclosures and cabinets and other things, but at the same time we will see the same slide again in the upcoming slide. Vacuum blasters, drappers, water curtains, wet blasting and reclaim systems. So, normally you can use this type of things to control the emissions. Wet blasting control the particulate matter emission. Normally, if you see the air, compressed air and abrasive particles, what will happen? There is a chance of this particulate matter goes up because the density is very low. If you are using a water based sand blasting, what will happen? This water will have high density compared to air, so it will take down into the reclaim systems. So, fabric filters are used to control the emissions from the enclosed blasting. Normally, fabric like mask or some of the cabinets which you have the filters and other things can help for the emissions control. These are the safety precautions. If you see in the figure 1 and figure 2. In the figure 1, he is not using any type of apron or something, but he is just using a mask, some of the handkerchief type of thing. So, there will be always chance that the particles can enter like this or particles can enter like this also. Okay. So, you should use professionally very good apron, at the same time mask and other thing, goggles and other things, because there is a heavy chance that this particulate matter can enter into the eyes also. Okay. At the same time, this may also fall on hands. So, since the velocity of this particulate matter is very high, this may damage the hand and wherever the exposure is there. That is why you always should give proper apron, gloves, mask and other things to the operator, so that the people will save their life and they will be healthy and they will work more and more for the company. Okay, this is what we have seen earlier. At the same time, this also is an alternative to have the emissions under control. So, you can use the atomic sandblasters wherein everything will be done inside. Okay. Inside everything will be done, so there won't be any much problem. In the cabinets also, you just put your hands and you do whatever you want inside, and this cabinet also will be completely covered. Okay. Much more details I have talked in the previous slides, so there won't be much things. The operator in these two cases is not directly exposed to the abrasive particles. There may be very minute, but it will be very less. So, there won't be any problem from the point of health if you are using automatic sandblaster or blast cabinets. Applications of sandblasting. If you see the applications, the primary applications normally people will be using for the wood cleanup and restorations. Normally, if you want people want to use for the wood cleaning to get the shining on the wood. Later they will paint with the shellac and other things, but before that one the people will be used for texturing generation on the wood and other things. So, people will be using for shipping industry, so they will do for the anti-foul coatings. Suppose sometimes these coatings will be removed, so they want to remove everything and they want to coat it again, or they want to create a super hydrophobic surface so that they can coat the good coatings on top of it. For that applications, people will use the sandblasting applications, And manufacturing parts cleanup. So if at all I want to clean these type of engine blocks or big components which are complicated, so that people can use for cleaning of these things. And automotive restoration and body work. Normally if body is not good, so you can recover it, like we have seen the rim of a wheel which we have seen in the previous slides, where it is rusted, so you just do it and you make it like a look like a virgin thing. Some of the other applications of sandblasting is glass industry. In the glass industry you can do the painting type of thing, or you can cut as per your requirement shapes. At the same time you can have a beautiful sculptures, suppose complicated sculptures which you want to do. You can use a fine nozzle and you can generate the textures on the glass. At the same time, nowadays people are very fond of this faded jeans. So if at all particular location has to be faded on a jeans, so or you can create some of the fades in a fine texture, so you can do. At the same time, if at all people want to tear it, tone jeans and other things, you can go for these fashion things. So this is one of the technologies that people are using. Chips are there to be drained. At the same time, if at all I want to give some lubrication to the parts while doing the finishing operation, you can go by 3 methods. One is a batch addition, compound or liquid. Along with the liquid you can add. Assume that I have a mineral oil along with the water. If I want to add, you can add now after 1 hour or something, that is called batch. And recirculation system you can use. Continuously you will throw, or continuously you will pump this liquid and continuously you recirculate it by using the filter system. At the same time, flow through the system, that is the continuously you add and you dispense it, this type of compounds. Okay. Compounds may be selected to perform some of the functions like condition water and pH of the wet surfaces. Normally whenever you want to do the finishing of this bio implants and other things, you have to control the pH on the surface. For that purpose you have to use the compound. And the cleaning the parts and keep the parts continuously cleaning, because if at all some surfaces are sheared or burnished, then you have to do the cleaning operation. Assume that the peak deformed into the valley, then it will be create lot of problem whenever you go and use for the application, certain applications and other things. Separate the and cushioning parts against the damage if required, and control form. Normally what I mean to say is that cushioning the parts against, sometimes parts and parts are hitting inside, because it is a random process which is a mass process or a batch process. So if at all I am pumping this type of liquid or the compound, what will happen? There will be a cushioning between the components. Remove the tarnish or the scales. If there is any scales formation is there because of the abrasive or because of the part to part contact or something, then you can remove this one. The part control color. So the color of the thing also you can improve. Suppose if at all I want to put certain colors, so you can add along with this compound. So that assume that I want to add a green color, just add the green color along with this compound, so that the particles also will become slightly green. At the same time your components also maybe become some green color. Develop the maintain lubricity by forming, prevent the corrosion, parts, metallic media and equipment, and provide the cooling. Normally the most important thing that you can do is there will be a temperature generation, depend on amplitude that you are giving, depend on the velocity that at which you are rotating, there will be a lot of temperature generation possibility is there. For that you can cool it. That's why water plus lubricant plus some of the other things, all rheological additives will be added for this particular thing, so that you can overcome some of the problems that are in the vibratory mold finishing process. We are going to see is the tumbling process. If you see the tumbling, the other name for tumbling process is rotary barrel finishing process. In the introduction to rotary barrel finishing process or tumbling process, it uses the horizontal oriented barrel of hexagonal or octagonal cross section which parts are mixed to rotate the barrel at the speeds normally 50 to 10 to 50 revolutions per minute. Normally this finishing will be done by landslide action. In the previous one, what will happen, vibratory bowl feeder will be there and it will be rotated like this. In this one, you will have a landsliding. Media and parts are raised in the barrel and rotates, top layer tumbles down due to the gravity. Normally you can see here landsliding type. So this type of things, it is moving. Once it reaches to here, the barrel, what will happen, it is moves. This looks like a landslide. These are medium parts and others are mixed here. You have abrasive particles like vibratory bowl finishing process. You add here and you will rotate the bowl. Okay, whenever you rotate the bowl, what will happen, which are the at the top level, it will slide to the bottom. So it will action is like look like a landslide. And the drawbacks of this particular process is that it is very slow, noisy and large floor area space is required. Basically, it will create lot of noise in the manufacturing area. So you can have a room separately where noise proof and other things you can do from the outside, and you just run these multiple machines and just you can control from outside. So rotary barrel finishing you will have normally for the mass finishing applications. At the same time, good for shaping to difficult to achieve controlled finishing processes. At the same time, non-uniform finishing due to random contacts, because your abrasive particles will have a random touch or randomly impinge on the components. That's why you will get random surfaces. The first variety of this one is centrifugal disc tumbling process, where it is a vertical axis. This is a vertical axis about which it will rotate, so that all parts and abrasive particles will be rotated. The other version is you will have a horizontal type. Okay, one is the vertical type, wherein it will rotate about vertical axis, another one is horizontal. So some of the components are very good for the vertical, some of the components are used for this horizontal. Normally landsliding and other things will be common for the horizontal, that is centrifugal barrel tumbling process. Landsliding is common. So in centrifugal barrel tumbling, as I said, the axis is horizontal. So the summary of this particular class, we have studied superfinishing process, sandblasting process, microblasting process. Thank you for this particular class.